Hello folks, this is John Kurt. I'm the owner of Imagine What, which is a CAD services provider. And I'm going to do a short video here to demonstrate that CAD software is CAD software. I continue to get the question, what do I draw in? And that's a kind of a silly question because it has nothing to do with what you're going to get. I'm not giving you my native file. I'm going to be giving you a step file or a DXF file or some sort of file that's compatible with your system for the 3D model, and I'm going to provide you all your paper spaces, your 2D drawings in again another format that your system will accept. So anyway, just kind of follow along. I'm going to be drawing a simple part and talking a little bit about it as I do so. Thanks. So to prove my point, I'm going to draw a couple cubes. I'm going to draw in different formats because I want to demonstrate that there's a lot of different ways to get the same result. The first one is going to be an ACES solid. It's going to be off the 3D tool palette. And the second method for drawing the cube will be by extruding a rectangular 2D profile. And then I'm going to resize both to be exactly the same so you can see there's no difference between one or the other. And just for your information, I've got all the accuracy set up on this particular drawing for an accuracy of 3 decimal points and to round up at round off at 5,000. So that's how I got it set up. I can give you any accuracy you want out to 6 decimal places if so desired. Also, I will warn you, you're going to be seeing my mouse cursor moving around, and you're not going to see it doing anything, and that's because for whatever reason a pop-up or a drop-down menu does not display on the screen capture software that I'm using. So what I'm doing when you see that cursor moving around doesn't look like it's doing anything is I'm actually setting up properties in a drop-down menu that you can't see. Both cubes at this point should be identical. On the x-axis they should be 2.5 inches, on the y-axis should be 3 inches, and on the z-axis it should be 2 inches. And in a minute here I'm going to do a radius of 0.060 on the edges, and then we're going to go ahead and drop some tapped holes in it for some bolts. Well, I said that wrong. Actually, I'm going to do the tapped holes first because I want to have a nice corner edge to work from. In TurboCAD, to do a tapped hole, I take a point and I locate it, and then once those points are located where they're supposed to be, I go ahead and I set up all the diameter of the hole, the depth of the hole, the thread pitch, and how far the threads need to go into the hole. All that's done. You won't see me doing it because it won't show up because it's in a drop-down menu. But then I'll go ahead and click on each point, and you will see the threaded hole appear. What I'm hoping to dispel here is this myth that unless you draw in SolidWorks or Inventor or AutoCAD or 360 or some special program, that somehow the accuracy of the part that you're making is going to be deficient. And when it comes to CAD software, that's incomplete, it's inaccurate, it's not true. If you've got good CAD software, and I do, I draw in TurboCAD 2019 Pro-Platinum, which is the top level program. It's going to give you the same accuracy as, for example, SolidWorks. Now, I will say this about programs like SolidWorks: they are good for engineers who do stress analysis, need to know center of gravity, a lot of different things like that that's useful for an engineer. But I'm a drafting person. All I'm going to do is give you your 3D CAD models and your paper drawings. The engineer is the one who comes up with all the stress analysis and what the thing should look like and what it should be made out of and blah blah blah. I just take directions from the engineer. So now we got our 1032 bolt holes in there, and we got a 0.060 radius on the edges. Now I'm going to drop a 1-inch diameter hole through the part from the top to the bottom, and then I'll do some work on the dimensioning, show you how the dimensioning works and how the drafting palette in TurboCAD works. Everything that I draw is in 3D. When I do the 2D portion of it, the TurboCAD drafting palette will go ahead and give me all the views that you're accustomed to when you're looking at a 2D drawing, such as the top, the bottom, the front, the left side, the right side, the back side, and I can give you sectionals with it. So I'll show you that. It's very easy and it's very accurate. I'm also going to put a 0.12 lead-in chamfer on this 1-inch hole, both top and bottom, because it's so that a pin can fit through there, and so you want to be able to hit that hole easy enough. So you'll see that here in a second too. And again, you're going to see a lot of movement with the cursor. It's not going to appear like anything's happening, but what I'm actually doing is when I do the lead-in chamfer, I have to set the parameters on that. You're just not seeing the drop-down menu and me selecting the parameters, but it's all set up. And again, that's where the accuracy of a good CAD program comes in. Everything has parameters to it, and those parameters are adjustable. We give you exactly what you want. If you want a 45-degree chamfer on it, we'll give you a 45-degree. If you want a 60-degree, we'll give you a 60-degree. You tell us what you want, and that's what you'll get. As I open the drafting palette, again, you'll see some hesitation there. That's because I'm selecting the coordinate system, the entity coordinate system. I always select world because otherwise it gets confusing. It depends on who drew the part, what particular coordinate system they were using. If I go by world, that's a kind of a given. Everybody has a world, so I always make sure that that's selected. Anyway, now you're going to see me putting out several 2D images that can be dimensioned. The first one's going to be an isometric southwest. The second one will be the top view. The third one will be the front view. The fourth one will be the left side view. And then I'm going to do the sliced views. I don't need to do bottom. The bottom and the top are going to be the same, and I don't need to do the left and the right. I only need to do one of them because they're going to be identical. Everything's uniform on this part. So anyway, and I'll show you how to dimension it. And again, this is as accurate can get. So it doesn't matter if this is being drawn in SolidWorks, or if it was drawn in Inventor, or whatever program, CATIA. It's only going to be as accurate as I tell it to be, and I told it to go out 3 decimal places and a half thousandths. So that's where we're at with the accuracy. So what I'm going to be doing next is I'm going to have to label all these views so that the end user knows what they're looking at. That'll take a little bit of time. So while I'm doing that, let me explain to you what you're looking at on the screen. If you look over in the left lower corner, you'll see those boxes change and light up and highlight, and numbers change, and so on and so forth. That is called the command center. So when I select a tool and I have to give it some parameters, or I need to change the parameters, you'll see me do it down there. If you look at the lower right-hand corner, you're going to see the X, Y, Z. Those are the geo coordinates. That is what is sent to your CNC machine. Each CAD model has its own geo coordinates, and so your CNC machine will use those to identify where the edges are, where the holes are, blah 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 blah. If you look at the left-hand side of the screen, those are, generally speaking, all my 2D tools. And then if you look at the right-hand side, it's called a palette director there. That's where I have my selection information. If I click on a particular part, it'll give me all the parameters that have been programmed in there. I can edit and change any of those, so I can delete them if I want. So I can do a lot of things there. I also have all my 3D drawing tools there. There's a tab there for layers. There's a tab there for the drafting program, and there's many, many more I can drop down, but those are my most common ones. Okay, now that I got the views labeled, we'll go ahead and start dimensioning it. Fortunately, I've already got the dimensioning parameters programmed in. Each drawing, you have to reset the parameters for the dimensioning, because if you're working on, for example, a small part like this, which is a couple inches big, obviously your arrowheads and your dimensions need to be readable within a couple inches, so they're going to be fairly small. But if I were working on a very large object, let's say I was working on a house, which is, instead of inches, it's many, many feet or meters, I'm going to have to size my arrowheads and my fonts and everything, so that when you're looking at the entire blueprint, you can read these dimensions. So each drawing is basically set up based on the size of the parts that you're going to be viewing, and there's an awful lot of parameters we can put in when it comes to dimensioning. I can give you any measurement you want. It doesn't matter to me whether it's metric or it's American. I can give you both. But what is important is you tell me what your program set up to look at, because that's going to be the primary measurement. I can give you two different measurements. I can give you, for example, metric English, or I can give you English metric. The primary one's always the first one. So I need to match my primary with your primary. That's important. But other than that, I can give you fractional measurements. I can give you architectural measurements. I can give you engineering measurements. I can give you all kinds of measurements. And I can give you tolerances too. We have callouts for tolerances. I can add, edit. I can put notes in the dimensions with dimensions. So I have a lot of flexibility in what I can do with dimensions. Okay, so I don't know if you notice this or if you recall it, but as I dimension it, the dimensions on these from the drafting palette is exactly what I programmed in for the model part. The X is going to be 2.5 inches, the Y is going to be 3.0 inches, and the Z is going to be 2 inches. So what you're seeing here is that whatever I draw, that's exactly what you're going to get. And I go back to my point about, does it matter that I'm drawing in TurboCAD and you have SolidWorks? Absolutely not, because when you open up this CAD model in your program, it's going to be exactly that. X is going to be 2.5, Y is going to be 3, and Z is going to be 2, period. There's not going to be any margin for error, because you don't see any margin for error. Exactly what I put in there is what it's dimensioning out to be. Now, if I put in only 1 decimal point and you're looking for 3 decimal points or 4 decimal points, then you're going to be disappointed. So you have to tell me what parameters you're looking for, because when I program it, that's exactly what you're going to get. So that's where the communication is important between the engineer and myself. Once I understand what you're looking for in terms of company drawings and so forth, generally we only have to go through it once. Also, if you can provide me your title block, how you like your paper space to look, I will make my paper space look exactly the same, so nobody will know the difference. When you import it into your system, it'll be as if you drew it yourself. Now that said, once you import the CAD model into your program, no matter which program it is, SolidWorks or Inventor or CATIA or whatever, you can modify it any which way you want, and it's going to work with all your tools, blah blah blah. Now what won't transfer over typically is, in my program I can give it certain type of physical properties, such as I can say I want smooth aluminum, and it has nothing to do with dimensioning or anything like that, but when it comes to rendering, it gives me a beautiful render. Now you're going to lose all those rendering properties because your program won't recognize those same properties as my program. So if you need to render, either you can have me render it, or you're going to have to set up your own properties for each part. But that's the only thing you lose. You're not going to lose any accuracy on the part. You're not going to lose anything. So you're just going to lose photorealistic rendering. That's all you're going to lose. And that's one of the services I offer. So pay me for it and you'll get it. So we're pretty near the end of this right now. We made our little part. This particular drawing, just to give you an idea, I would probably charge $20 to do. It's not a very, it'd take me about an hour by the time I got everything set up, drawn, and packaged where I can do a deliverable. But keep in mind, my deliverables are generally the CAD drawing, the CAD model, and your paper spaces, your dimension drawings, assembly drawings, detail drawings, things of that nature. I can do, and this is mostly for people who want marketing materials or who are doing proposal drawings for a project, trying to win a bid on something. I can do proposal drawings, and I can give you photorealistic renderings. If you go to my website, www.imaginewhathouston.com, all those items there on that website that look like photographs, those are actual drawings. That's how good I can get with this particular program for you if you require it. And you also a page on that website that will show environments. In other words, I can take that model and I can drop it into a backdrop, like at a seaside, and you'll see that there's a page called environments on the website. So there's a lot of things I can do. Keep in mind, I'm not an engineer. I am a drafting person. My bread and butter is basically providing CAD models and 2D drawings. It is not a requirement, or it's not going to take anything away from your deliverable, because I draw in TurboCAD and you draw in Inventor, okay? SolidWorks does not give you a better product than TurboCAD does. It may give you certain features that is useful for an engineer, but are not useful for a draftsperson. And keep in mind, the draftsperson is 80% of the project. The engineer is only about 20%. Okay, most engineers don't draw. They will give you a paper sketch on a cocktail napkin and say, this is what I'm looking for. And you send them the drawing and they'll say, no, I want this change, I want that change, blah, blah, blah. The grunt work, the thing that takes all the time, is getting all your assembly drawings, your detail drawings, your dimension drawings set up accurately so that you can run production. All right, so I think that's it. I hope to hear from you, and I hope I put to bed some of this unrest about, oh gee, I've never heard of TurboCAD before. Go look it up. It's in the top 10 best-selling CAD software programs out there. Thank you. This is John Kurt. Give me a call.